This question is asking which of the following is not a possible product, major or minor, of the following reaction. So this reaction has chlorine, Cl2, and it has H-Nu, which is light. The light is a big factor because it helps us to realize that this is going to be a radical reaction. So we have light as kind of the radical initiator. So this question is specifically for chlorination, which is kind of the less selective halogenation process for halogenating an alkane via this radical process. So we generally notice that we make lots more products with the radical chlorination. So the key idea for this question is to think about where we have carbon to hydrogen bonds. And that's important because one of the key steps in the propagation is a hydrogen abstraction. So we have to be able to remove a hydrogen atom from the carbon to make the carbon radical. And then we want to also be looking for the most stable location on the alkane in order to make the most stable free radical. So let's take a look at this example. In this case, we have kind of multiple locations with hydrogen atoms. I'm going to draw them in here. All of the hydrogen atoms on that tert-butyl group are equivalent to each other, so they all make the same product. So any one of these hydrogen atoms can be abstracted to make possible products. Okay, so if we're looking for all the possible products, then we need to just consider which hydrogen was removed in each case. So if we take a look at molecule number one would come from this free radical right here. It's a secondary radical. So we'd be removing that hydrogen atom right there on the molecule, and then making that chlorination product. We'd also make its enantiomer, the dashed back chlorine. Molecule two comes from this free radical, which is tertiary. And the tertiary radical is going to be our most stable radical. So this one would lead to the major product. So this would be kind of the major product of this reaction because it comes from the most stable radical. Molecule three is kind of problematic because if we take a look at the carbon that previously had 3 methyls coming off of it, we can see in this example that there are only 2 methyl groups. So this molecule is not even the same molecule that we started with. So we've essentially replaced a methyl group with a chlorine. And so that's not going to happen in this alkane halogenation. Kind of the key fact or the key kind of thing to keep in mind is that the carbon atom that was part of the tert-butyl group has no hydrogen attached to it. So quaternary carbons like this aren't going to be able to undergo hydrogen abstraction to become brominated or chlorinated. If we take a look at the fourth molecule, this one is coming from a possible radical intermediate. It's not very stable. It's a primary free radical, but it's technically possible. It would be a very minor product. So molecules 1, 2, and 4 are all legitimate possible products, major or minor. Only molecule 3 is not possible. So the answer to this question is C.